So I'm going to continue on doing some more electron configurations here and then get into configurations of ions. So up until this point, we've done 3 examples. So using your periodic table, let's do bromine, Br. Okay, so it's right there. So see if you could write the electron configuration of bromine, the full one, and then write the noble gas configuration. So give yourself a pause and pause the video and see if you could write it. I'm going to start writing it now. So again, the argon is going to be the noble gas that you use. You always go to the row above and look at what the noble gas happens to be. That's going to be argon. Then it goes 4s2, 3d10, 4p5, because that's again the end of, or that is the label on the column there. So I am going to introduce you to the last block, which is the F block. And please understand that these blocks go in right here. So if you want to draw arrows, okay, they go in the 6th and 7th row, okay? They follow the S block, so it always goes S, then the P block, the S block, then the F block, then the D block. But the F block is a row number -2. So if I'm in row number 6, it's going to be 6 minus 2 is going to be a 4F. If I'm in the 7th row, it's going to be 7 minus 2, which is a 5F. So I'm going to do mercury as my example here. And mercury is right here. So if you want to draw that in your copy, or just use it off the periodic table. So mercury has a total of 80 electrons. So I'm going to just write it all down. I'm not going to talk through the whole thing. And I'm going to use the noble gas configuration because it's far easier. So if I go where mercury is, I go to the row above and I look at xenon. Okay, so I'm going to put xenon in brackets, put xenon in brackets. And then I got to follow what happens after xenon. So if I go over here, I'm in the 6th row. So it goes a 6s2, S always has 2. Then it goes 4f14, then it goes 5d10. So I'm going to write that out. So it goes 6s2, 4f14, 5d10, 5d10. So 6s2, 4f14, 5d10. All right, so that's how you incorporate the F block. So let's do one more, and then we'll move on to ions. So acetane is AT. So again, pause the video and see if you could write the electron configuration of that, and I am going to do the noble gas configuration. I'm going to do the noble gas. So pause the video. So this is acetine 6s2, 4f14, 5d10, and then 6p5. So after the 5d, it goes back to the p block. And so if you could do any of these in this these last 2 rows, you could do electron configurations in any circumstance. All right, so moving on to things that have charges, okay? So now I'm going to look at electron configuration of ions. And this should give you at least some background into why the charges are what they are on certain elements. So if you remember from your first year chemistry days, different columns on the periodic table have different charges. So oxygen, if you remember, had a -2, sulfur next door to it, or excuse me, fluoride, chloride, bromide, iodine, those all are -1. So there are different reasons for why, or there is a reason why it has the particular charge that it does. So if I look up sulfur, sulfur is a -2 charge when it becomes an ion. So if I am writing sulfur's electron configuration, it's going to be neon 3s2 3p 4 if it's just sulfur. But if I have a -2 charge, what has happened is it's gained 2 electrons. Well, where are those electrons going to go? They're going to go into that p energy level and orbital and fill it into a p6. So the whole point of why sulfur is a -2 is by where it is on the periodic table, okay? So sulfur is essentially 2 away from argon. So it wants 2 more electrons to have the same configuration of noble gases. And noble gases are the most what we call stable configuration. So that is why it does what it does. So it has the same configuration as argon. And that is a way you could write S2- electron configuration. Okay, well, let's go to the other side. Let's look at something like magnesium. Okay, let's look at something like magnesium. So magnesium is right there. It's in that S2 column. Okay, so if I write magnesium, it has 12 electrons. It is neon 3s2 3s2. So it becomes an ion by wanting to become the nearest noble gas. So it doesn't make sense to go all the way to a 3p6 and add 6 electrons. That makes no sense. So instead, what magnesium does is it loses 2 electrons from its outermost energy level, which is the 3s2. So magnesium becomes what we call a cation. It becomes a +2 charge because it doesn't have 12 electrons anymore. It has 10 electrons. So it becomes the configuration of neon. Okay, so things on the left, okay, if you recall, the first column is a +1, second column is a +2. While over here, my halogens are -1, this is -2, this is -3. And that is because on the right-hand side, they like to gain electrons. On the left-hand side, they like to lose electrons. And so that's going to be a key in when we're looking at configurations. So let's look at 2 more examples here. Let's look at zinc. Okay, so let's look at zinc. So let's write zinc's electron configuration. So zinc is right here. Okay, zinc is right there on the periodic table. Okay, it's in the D10 column, D10 column. So I could write the noble gas configuration of argon. Then it goes 4s2 3d10. Okay, so zinc becomes a +2 charge. Okay, and you do not need to know what, the charges of these ions. I'm just going to say zinc is a +2. But what you're going to have to recognize is what is the electron configuration of that ion? So it means it is losing 2 electrons. So where is it going to lose its electrons from? Well, it's going to lose its electrons from its highest energy state. So even though we fill it in a different way, a 4 is a bigger number than 3. So that means this is a higher energy. Those electrons in the 4s orbital are a higher energy state than the 3d. So that means the electrons are going to be lost here from the 4s before they start coming out of the 3d. So if I'm writing the configuration of zinc 2+, I write argon. And what you could do, this is a nice shorthand that I'm fine with. You could just cross out the 4s2. Or if you like the neatness of it, you could just recognize the 4s goes away and you are left with the 3d10. I'm okay with the cross out because that shows me that you understand how to do that. So let's look at iron. Okay, we already did iron's electron configuration. Okay, so we have argon, 4s2 3d6, 4s2 3d6. Well, iron is in that middle block, and these metals sometimes have multiple charges. So iron has a +2 and a +3 charge. You don't need to know that it's a +2 or a +3. But what you need to know is how to write their electron configuration. So if they are a +2, that means it's lost 2 electrons. It's going to lose it from the 4s2. So again, I am fine with you writing out the electron configuration of the neutral atom and then crossing out things. I'm fine with that. Or if you want to make it neater, you could do it otherwise. Now, if this is a +3 ion, that means it's lost 3 electrons. So 2 are going to come from the 4s, but then 1's going to come from the d. So I could take the 6 and make that a 5, or again, neaten that up and just make it argon 3d5, either way. But again, that's how you do configurations of ions, especially in that middle D block. They always come out of the S first, or the higher energy state, and then you start taking them out of the next energy state. If you had a p orbital, you would take that out first, and then the S, and then go back down to the D orbital. So that's how you do ion electron configuration.